this video, we are going to answer exam questions from past papers involving differential calculus. We are going to explore some of the questions that involve in finding the equations of the tangent and the normal, and also now to come up with the points of the stationary and also the turning points. Make sure you grab your pen and your calculator there. Let's dive into the topic. At the end of this video, you will not fail to answer a question on this topic. So our question 1 is saying, find the derivative of y equal to, so we have been given y equal to 2x to the power 3 minus 2x squared minus 3x plus a 1 with respect to x. So now when they say with respect to x, they just mean you say dy over dx will be equal to, now here 2 and 3 will multiply, so in short the coefficient will multiply with the power. In this case it will be 2 times 3, which is 6x, and then the power must be reduced by a 1. Negative 2 will multiply by 2, which is the power, and then it will be negative 4x. The power must be reduced by a 1, and then when you have a variable and the coefficient, just get the coefficient. In this case it will be just negative 3, and the constant number becomes a 0 there. Therefore you say dy over dx will be equal to 6x 3 minus 1, that's a 2, minus 4x to the power 1 minus 3 plus a 0, which is just okay. So we're going to say dy over dx will be equal to 6x squared minus 4x minus a 3. So this is your differentiation with this kind of question. Now you might be surprised, like, how is it possible for me to differentiate in this manner? So you just have to know this formula. We say a multiplied by n multiplied by x to the power n minus a 1. When you master this, it will be very easier for you to be dealing with differentiation like that. So what do they mean? So here a, it is the coefficient, n, it is the power, and then that power must be reduced by a 1, and then x, it is the variable in this case. So in this case where we had 2x to the power 3, which simply means that 2, it is a, therefore we say 2 multiplied by the power, which is n, therefore the power here it will be a 3 multiplied by our x, which is our variable there, and then this same power must be reduced by a 1. So we say 2 times 3, that is 6 times x, that will be 6x, and then 3 minus 1, that is a 2. That's the reason why we came up with a 6x to the power 2 there. So now we must use this formula to deal with each and every term in the equation. Now the other thing which I would like to explain is, in the case where we had negative 3x there, how is it possible that we just came up with a negative 3? Remember, still we are going to follow a times n times x to the power n minus 1. Our a in that case, it is what? It is a 3. So here you just say negative 3 multiplied by what is our power. So here if it is like this, which simply means that our power, it is a 1 there. So you are going to have a 1 multiplied by our x, which is there, and then this same power must be reduced by a 1 according to the rule. Therefore you are going to have negative 3 times 1 times x, it will be negative 3x to the power 1 minus 1, that is a 0. Remember the rules of indices. one of it says any number or letter to the power 0, it is equals to a 1. So in this case it will be negative 3. Therefore here we're going to have a 1. Therefore negative 3 times 1, that will be a negative 3. That's the reason why we just came up with a negative 3 there. So now, whenever you have a number which is just, maybe it can be 2x, it can be 4x, it can be negative 5x, always your differentiation will end by remaining with the coefficient there. The variable will disappear. In this case, which is x, will disappear. So now, for the last part which I would like to explain is why we came up with a 0 where we had a constant number which is a 1 there. So one thing that you have to understand is that if you have this, what do we mean? Which simply means that we are simply having 1 times x to the power 0, or we can just say it is same as x to the power 0, because x to the power 0, it is just a 1 there. Now, how is it possible that a 1 became a 0? So in that case, since we have agreed that 1, it simply means we are just having x to the power 0 there. So what you do is you just say x to the power 0. So here we know that the coefficient of x, it is 1. So you say 1, the power, it is 0. Remember, we are going to have a times n times x to the power n minus 1. So our a, it is a 1, our n, it is a 0 there, times our x to the power 0 minus a 1 there. So 1 times 0 times x, or in short, let me just say 1 times 0, it is 0, of course, times x to the power 0 minus 1 to be negative 1. But 0, when it multiplies with x to the power negative 1, it will be a 0 there. So that's the reason why a constant number becomes a 0 always. Even if when we have a 10, a 20, 25, a 50, always if it is just constant, remember that when you're dealing with differentiation, it will become a 0 there. That's the reason why we came up with a 0 in the case of 1. Okay. Our next question. You can pause the video and then you try it by yourself. You just have to remember a times n times x to the power n minus 1. Just remember this, you'll be able to solve this question. So the question is saying, given that y is equals to 4x to the power 3 minus 3x to the power 2 plus 5x, find dy over dx. So in short, we are just finding the derivative, the same thing which we have done on the first question there. That's the same thing which you have to do here. So pause the video and then you try it by yourself. Okay, I hope you have done that. So let's confirm. So here, what did we say? We said here to become dy over dx equal to, and then we have agreed that 4 will multiply by 3, which is a, which is 4. So it will be 4 multiplied by our n, which is 3, times x, which is here, and then the power, which is 3, must be reduced by a 1. That's what we agreed. And then we are going to have negative 3 is going to multiply with n. In this case, it will be a 2. So times a 2 there. If you want, if you may not be too smart, what you can do is just include the brackets here so that you don't mess up with the work. So here to be negative 3 times 2, and then you say multiplied by x to the power 2 minus a 1 there, plus here we already agreed that if it is a a coefficient and a variable, just get the coefficient. In that case it will be just a 5 there, and then you know that these they are in brackets so that you don't interfere with them. So our dy over dx will be equal to, now remember, to be 4 times 3, that will be a 12. Now 12 times x to the power 3 minus a 1. Here to be negative 3 times 2 times x, so it will be negative 3 times 2, which is negative 6. Negative 6 times x, that will be x to the power 2 minus a 1 plus a 5 there. So you say dy over dx will be equal to 12x to the power 2 minus 6x to the power 1 plus a 5. Our final answer, dy over dx, will be equal to 12x to the power 2 minus 6x, where there is 1, we know that that is the power, so it is invisible, plus a 5. This is your answer. But most students make mistakes whereby when they have differentiated like this, they still want to differentiate. In this case, it is a mistake if you say dy over dx will be equal to 12 when you say 12 times 2 again times x to the power 2 minus 1. Like this, that's not your dy over dx, then you're going to the other thing. So you just have to differentiate once. Please make sure that you know that mistakes, you'll be aware of it, because it is very important that you know what you are doing. You are just differentiating once, not twice. Okay, we move on to the next question. I would encourage you to pause the video as well on this question so that you solve it. So the question is saying differentiate. We have y equal to 1 over 3 x to the power 3 minus 5x to the power 2 minus 2x with respect to x, which simply means that you must say dy over dx. So here we are saying dy over dx will be equal to, when we say 1 over 3 times 3, what are we getting? So here we are just simply saying, when you multiply, or if you want, when you just say 1 over 3 times 3, this will be equal to 3 over 3, which is just equal to a 1. So here it will be just a 1. Now that 1 that you are going to have is going to multiply with x to the power 3 minus a 1, because we agreed that the power must be reduced by a 1 there. Now what you do here, you have negative 5 x to the power 2. Remember, negative 5 times 2, that will be a negative 10 times x to the power 2 minus a 1. When you have something like this, what do we say? Just get a negative 2 like that. Dy over dx will be equal to 1 times x to the power 3 minus 1. We know that it will be just x to the power 2, because 3 minus 1, it is a 2, minus 10x to the power 1. But we know that there is no harm if we just write 10x, because 1, it represents the power which is invisible here. X itself, it's enough, it is showing that I'm just alone here. And then you're going to have a negative 2 there. So this is your answer. Now on the hub, so we have the hub where you're going to find a full video of this same topic and other interesting topics like mensuration, earth geometry, trigonometry, etc. We also have free PDFs where we have questions compiled with answers of this same topic and other topics as well which I've mentioned. So you might do well just to visit the hub. The name of the hub, it is Transcendent Study Hub. You'll be able to find everything there. Okay. We move on to the next question. Okay. So we have this interesting question which is saying the equation of the curve is, we have been given y equal to x to the power 3 minus 27x. So this question is very interesting because it's very important that you pay attention to it. Yeah. So now they have said find the coordinates of the turning point of the curve. So what you do first, you find the dy over dx. So you say dy over dx, the same thing which we have done. So here the power, it is a 3, but the coefficient, it is the 1 which is invisible. So it will be 1 times 3, it will be 3x to the power 3 minus 1. Here remember, as long as there is a coefficient and the variable, just get the coefficient. Therefore the coefficient will be just negative 27. Therefore our dy over dx will be equal to 3x to the power 2 minus 27. So now, one thing that you have to understand, which is a very new thing here, of which you just have to know, is that dy over dx is equals to m. What is m? M, it is the gradient. So the gradient, it is m, like that. So now, this gradient on the stationary point, it is equals to 0. So the gradient, it is equals to 0. So in that case, we are going to say m will be equal to 3x to the power 2 minus 27. And then we have said that m, it is equals to what? 0 at the stationary point. So, or at the turning points. So you might say stationary point or turning point, it is one and the same. So now here to be 0 equal to 3x squared minus 27. So now, since we are finding the coordinates, and then you understand that in finding the coordinates, you must have x coordinate and the y coordinate. So now here, just make x to be the subject of the formula. So now in that case, you are going to say 3x squared minus 27 will be equal to 0. What I've done here, I've just taken 0 to the other side. So now you make x to be the subject here. So what you do here is to be 3x squared equal to 27. So it will become positive 27 when it goes to the other side, and then you divide both sides by a 3. X squared will be equal to, you can use your calculator here if you're not good with if you don't have to make mistakes. So you can just say 27 divided by 3. It will give you a 9, like that. So now when you have a 9, you introduce the square root because we want to get rid of the squared. And then upon introducing that, you're going to understand that you have to introduce positive or negative as well. So in that case, it will be x equal to positive 3, or x will be equal to negative 3. So now we have found the value of x, but we need to find the value of y. How do you find the value of y? You get the original equation from the question. So you say y will be equal to x to the power 3 minus 27x. So now we start by the positive 3. When we use positive 3, y will be equal to what? So it will be 3 to the power 3 minus 27, open the bracket here, we're going to have a 3. So when you say 3 to the power 3, when you use your calculator there, it will give you 27. So y will be equal to 27. And then you're going to have negative 27 multiplied by a 3, which is 81. So here we're going to have 81. So y will be equal to, now when you say 27 minus 81, what are you getting? Negative 54. So here you are having negative 54 when you use positive 3. So you can just write on the side saying you have positive 3. When you use positive 3, you are going to get negative 54, like that. Now we haven't used the negative 3, so now let's try to use negative 3. What are we going to have? So you just say, you use the original equation again, which is y equal to x to the power 3 minus 27x. Y will be equal to x, which is a negative 3 to the power 3 minus 27, open the bracket here, we're going to have a negative 3. Y will be equal to, when you say 3 to the power 3, remember we are getting 27. Now negative is going to multiply again by itself 3 times, which is will be just a negative. So it will be just negative 27. Negative times negative, here to be positive. 27 times 3, what are you getting? You are getting 81. So when you get your 81, you write there. So y will be equal to, when you use your calculator, you are going to have negative 27 plus 81. You are getting 54, which is a positive. So now you can say, and when we use negative 3 as x, our y, we are getting positive 54. So these are the coordinates of the turning point which they are looking for. So remember, first find your dy over dx. Thereafter you find you make x to be the subject, knowing that m, which is the gradient, is equals to 0. And thereafter you have to find the y coordinates, because in coordinates you're supposed to have x and y. Okay.